Hi everyone, I'm back in the undergrad lab and I'm polishing our samples. I'm doing the same sort of procedure I did with our aluminum samples. It's a lot more difficult because steel is stronger than aluminum, so we'll see that in our hardness values and things like that. I also wanted to show you one other complication. So these are two samples. They're at an intermediate polishing step, so you can still see those scratches. What I did though is I just left a little drop of water on the one that's closer to me, okay? Now, what you'll see is if I wipe this off, that it's still discolored in that spot, okay? That's just the formation of iron oxide or rust on the surface. And I just wanted to show you that even just with a little bit of water and leaving it out on the lab bench for a few minutes, that can start to be a problem. So we'll need to be careful when we're making these samples so that we make sure they stay clean, keep the water off the surface, but also make sure that we have this nice freshly polished surface to remove any oxides before we do any hardness measurements or etching of the surface. Hi everyone, we're back in the lab. The furnace is set at our set point of 925 and it's ramping up. So now I'm gonna go ahead and put our samples in. So just make it a little bit easier to do it at lower temperature. So I'm just setting these characters in there by themselves using these metal tongs. So one thing I'll mention is right now I'm just sort of using one hand, being a little bit casual getting these in here, but that's just because it's not too hot right now. So when I come back and I take the first sample out to quench it, what you'll notice is I'm going to set up a separate camera so I could be totally hands-free, have both of my hands ready. I'll even have some extra safety precautions on, okay? All right, so we can set this up, close it. We'll let this ramp back up. Once we get up to our desired temperature, I'll pop it open and show you how it looks. And then we'll wait until these samples create that FCC structure, and then we'll do our different quenching and heat treatment procedures. All right, so our furnace is almost at its point for the austenization treatment. It's at about 900 degrees C. I just want to open this up. I'm going to be very careful just to show you it's very hot in there. It's glowing red. Those samples are white hot, so we're going to be very careful when we take those out and quench those. All right, so we're ready to take the first sample out. You can see I have my safety jacket on. I have a face shield, and I'm putting on my high temperature gloves. So what I'm going to do is I'm going to use these tongs to get in there and get our first sample out. And then I have a bucket of salt water down here on the ground. I'm going to mix this in and quench this sample down, all right? So I close down the furnace again, keep everything hot. I took this sample and I'm moving around. So the salt water is keeping us from forming too many bubbles around it, as well as me shifting this around inside of this sample. So the combined effect of these two is hopefully keeping me from getting that Leidenfrost effect. Okay. So this has been quenched down. There's no more bubbles coming off. I'm going to take this and put this into a beaker of regular water. So I want to get that salt water off of that surface, and I'm going to rinse it in 2 stages, okay? Now, I'm not quite done. Remember, I have 2 martensite samples. I want to quench down another one very rapidly. and then that's going to be the one that I'm going to take and make this tempered martensin. Okay, so I'm going to go through that procedure again. I'll put my mask down, go in and grab that other one, and get that quenched out. So I'm not sure if you guys can hear it, but when I put this sample into the cool water, I hear a whoosh as that vapor layer is first made. As a sign that that water is reacting to my very hot sample. Okay? Again, these are glowing hot, very, very warm. I'm sort of stirring it around, moving in a figure eight pattern, trying to keep those bubbles off. After a minute or two, and I see that no more bubbles are coming off. Again, that means I'm below 100 degrees C. I can take and put this sample into my regular water as well. Okay? Now, my third sample, remember I want that to be cooled down, but not in the same rapid manner. I want it to happen and sit at a temperature just below the eutectoid temperature. All right? And we said that that would be 650 degrees C. So what I'm going to do is I'm actually going to change the setting on this furnace to 650. So that's the new target. And then I'm going to open this door to help rapidly, reasonably rapidly, reduce the temperature inside. Down to that 650. And actually my furnace is telling me something's wrong because it's too high, it's higher than the set point. That's okay, I know that's happening. So I'm going to pop this open. The temperature in that furnace is very rapidly going down. So it's at 850. See that that's very hot. Sitting here, I can feel all the heat coming off. So we're down at about 800. When this gets a little bit below 700, I'm going to close it back up. Okay? I don't want it to go too much lower. I don't want to have any weird transformations. I just want to be in that temperature range where that perlite can form. So we're at about 750 in the furnace. So it's a little bit hard to see on this camera, but in the back left, there's a thermocouple there, which is reading out that temperature. Okay, so it's telling me what it is inside of that area. All right, so we're at about 700. So what I'm going to do, once we get below 700, I'm going to close that back up. Okay. See what my temperature is doing. It's going back up a little bit. So I might open it and reduce the temperature a little more. My goal here is I don't want to go below 650. I want to sort of ramp down relatively fast and stay there. So 25 degrees away, I'm going to close it back up. My guess is that this temperature is going to go up a little bit. The system's fighting itself a little bit, and then it'll come back down. We'll let it sit there and equilibrate for a little bit of time, okay? So I'm not messing with the furnace anymore, so I can take off my face shield and my high temperature gloves. What I want to do, my last thing, is I want to show you these samples. So I took them from, I just had a second water beaker back here. Okay. These things are cooled down. They're not hot anymore. There's nothing dangerous about them. I just want to make sure I'm getting all that salt water off. So I'm going to pull these out. I'm going to dry off one. So one thing that happened is when I put this thing in this cold saltwater bath, cool saltwater bath, it very rapidly quenched down. And I didn't have to worry about it here, but if I, for example, had a really thin steel part, that rapid cooling could happen non-uniformly and the sample could warp or something like that. That's not really something to worry about with these. These are just blocks of material and we can sort of do whatever we want. But I will point out that this thing looks very different than it did before. It was shiny, well polished. All this surface oxide has formed. We gave it a lot of temperature. It didn't help that we put it in salt water. That was part of it too. But anyways, what we're gonna have to do is go and polish back, take this material off before we go and look at that surface and measure the surface properties. So we'll actually end up doing that next week. I'll show you how we can take that off. One thing we're gonna do is we wanna take that surface material off, but we wanna stay relatively close to that original surface, okay? So remember, we're taking this block that's really hot, putting it into a bucket of water. This block won't uniformly cool down. The outside is going to cool down faster than the middle, okay? So we're going to try to make sure we look at the outside of the structure, right? I'm going to take that other one out. It's going to look very similar. And it should. Basically went through the same process. Okay. I'm not too worried about making it perfectly cleaned off right now because I'm going to have to polish this sample again. Here you go. You can see that second one. So right now, these should have identical microstructures. They should both be a fine martensite because they were rapidly cooled down. And then we're going to take one of them and try to coarsen that martensite with the tempering procedure. Okay. So I will log off here and I will pop back on just at the end to show you the quenching of this perlite sample, and then also the quenching of this tempered martensite sample too. All right, I will be back shortly. All right, so we're back. It's been our 3 hours at our 650 degrees C, so we should have formed our coarse perlite. We're gonna go in and take this sample out, rapidly quench it in this salt water, and then rinse it off. So we still heard that large change in temperature. I'm mixing this around to try to not allow that air pocket around the sample to form. But it was a lot less aggressive. The sample was not quite hot this time. So a visual representation of the fact that we were at a much lower temperature. Right? I'm not seeing any air bubbles. Taken my sample. Done my different treatments. And now I have 2 of my samples ready. Take this out, dry it off. What's kind of cool is a lot of the outer shell, so some of that oxide that formed at high temperature, actually broke off when I quenched it. So you can see it's still pretty dirty, but find a piece that just flaked off. So a piece of that oxide flaked right off the surface. Okay. Let's pull another one off the surface too. So we have 2 of our 3 samples. The last thing to do is we're going to take and we're going to, at 500 degrees C, anneal one of those martensite samples. Just practical things with the day. I'm going to come back and do that tomorrow, but I'll bring the camera and take myself doing this and see that procedure as well. Hi everyone, it's the next day. We're ready to make our tempered martensite sample. So again, we'll turn on our furnace. I had put it on this last night before I left. So 500 is our goal. This is going to start ramping up. What we can do is pop our sample in there. I have one of the 2 martensite samples from yesterday. Gonna put it in the middle. So these samples, so that I can tell them apart, I went through and marked them 1, 2, and 3, so I know which is which. Sample 1 is our quenched martensite. Sample 2 will be our tempered martensite, and sample 3 was our perlite sample. All right, so we'll let this ramp up, and I'll come back after 6 hours and after we've given this the tempering treatment that we're targeting. And we'll quench it down and we'll have our 3 main sample sets. So we are at the end of our 6-hour heat treatment. Have a slightly different perspective here on the video so I can show you taking the sample out. It's not as hot, so I can use one hand and get everything done. Okay, so it's not red hot, but it's still warm. It's 500 degrees C in there. I'm gonna take this out and quench it down in our salt water. You could hear that sound when I put the water in, or when I put the hot piece in. So that's just forming those vapor bubbles, okay? As you can see, I'm moving it around to help make sure that we don't keep a large Leidenfrost situation going on. You can look at this thing. I don't see any new bubbles coming up from it. So I'm going to put it in my clean water with no salt water, or no salt in it, and I can turn this off. Okay? So now we have all 3 of our samples, and then next week we can start to investigate their properties and microstructure.